Okay, we are now in section 11.2, distributions of data. We're going to use shapes of distributions to select appropriate statistics, and we will also use these shapes to compare data between multiple sets of data. So, straight out of your textbook here, there are 3 photos of symmetric and skewed distributions. The 2 on the left and right hand side represent negative and positively skewed distributions. The one in the middle is a symmetric distribution, and there are some bullet points I want you to take a note of. The first bullet point on the left hand side of the negatively skewed distribution says that the mean is less than the median. When you have a distribution, a set of data, when the mean is less than the median, and the majority of the data are to the right of the mean, it tails off to the left. You can see this tail off to the left. We are talking about a negatively skewed distribution. On the flip side of that, if the mean is greater than the median and the majority of the data is to the left of the mean, we're tailing off to the right, it is a positively skewed distribution. Now in the middle, the mean and the median are approximately equal, and the data is pretty evenly distributed on both sides. That's called a symmetric distribution. Okay, some things to note here. When a distribution is symmetric, the mean and standard deviation accurately reflect the center and spread of the data. However, when a distribution is skewed, these stats are not as reliable. Recall that outliers have a strong effect of the mean of a data set, while the median is less affected. Similarly, when a distribution is skewed, the mean lies away from the majority of the data toward the tail. The median is less affected, so it stays near the majority of the data. The bottom line is this: if a distribution is relatively symmetric, the mean and standard deviation can be used. However, if we have a skewed distribution, there are outliers taking place, then we want to use the 5-number summary. A box and whisker plot is a way to identify the shape of a distribution. The position of the line representing the median indicates the center of the data. The whiskers show the spread. If one whisker is considerably longer than the other, and the median is closer to the shorter whisker, then we have a skewed distribution. Take a look at the 2 examples here of positively skewed and negatively skewed distributions. The data to the left of the median on the negatively skewed distribution are distributed over a wider range than the data to the right. Conversely, on the positively skewed distribution, the data to the right of the median are distributed over a wider range than the data to the left, and the symmetric one in the middle, it has the data that are equally distributed to the left and to the right of the median. So we would use the mean to describe, or standard deviation to compare data for something that's symmetric like that, where we would use the 5-number summary for skewed distributions that have outliers. What does a box and whisker plot show? The box and whisker plot is made up of the 5-number summary that consists of the minimum, the lower quartile, the median, the upper quartile, and then the maximum. The IQR is the middle 50% of the data. it is the upper quartile minus the lower quartile. So just to give you a visual, the item at the very beginning is the minimum, the item at the end is the maximum, the median is the second quartile, the upper quartile, we call that Q3, and the lower quartile is here, we call that Q1. And as I said, this is the interquartile range, and that consists of Q3 minus Q1. The quartiles are the medians of the lower and upper halves of the data set. If there are an odd number of data values, do not include the median in either half. And we will discuss that moving forward. Okay. So we have a set of data here. Our task is to create a box and whisker plot, and we are to find the interquartile range. So the first order of business here is to reorder the data from smallest to biggest. So let's do that first. Start with 11. And I like to cross these off as I work through the data items so I don't forget one along the way. I see 12 twice. See 13, 1, 2. I see 13 3 times. $14 looks like that comes up 3 times as well. Let's see, 15, see that once. 16, nope, 17 one time. 18 comes up a couple of times. 19, 22, and then 23. Alrighty, we have all of our data items in order now, and so to make a box and whisker plot we need a minimum and a maximum. We'll take 11 as our minimum, we'll take 23 as our maximum. Let's find our median, which is quartile number 2. We're finding our median here. So it looks like it's in between 14 and 14. Hey, it must be 14 then. Quartile 2 is 14. The lower quartile starts immediately after, so 14 and 11. 14 and 12, 12 and 13, so it's in between 13 and 13, which is the number 13, that's quartile number 1. The upper quartile is in between 18 and 18. That's kind of weird, but hey, it works out. So there you have it. You have your 5-number summary. Now let's put it all together. When you create your intervals, make sure they're the same and they are congruent throughout. I don't want you to go 0, 5, 10, and then 30, 35. Do not want that at all. Nor does Mrs. Rao or Mr. Long. Do us a favor, and when you create a number line with your intervals, make sure that they are all the same. Now, you must consider your minimum and your maximum, what type of range you have. In this example, you don't have a very large range, so going by ones on your number line is okay. Sometimes your range is 50, 100. You don't want to go by ones there. You want to increase your intervals, maybe go by tens or even 20, etc., things like that. So if I start here at 10 and I go up to, let's go to 20, 25, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. I probably could spread this out a little more. And these are the adjustments that you should make. It's not always going to be perfect the first time around. So if I start at 10, I can go 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. Alright, we'll extend that out. 23 is here. 11, 12, 13, 14, 15, 16, 17. Okay, now let's plot our 5-number summary. The min goes here, the max goes here, the first quartile is 13, the second quartile is 14, and the third one is 18. Draw some lines through it to create our box. Okay, this looks like a positively skewed distribution. The median is hanging over to the left with the shorter whisker, and the half the data to the right of the median is more spread out. And the whisker is noticeably longer. So I would say that this would be a positively skewed distribution. Now, our IQR from here to here is 18. So IQR is 18 minus 13, which is an interquartile range of 5. And we're done. So our second example for this lesson has the points scored per game by a professional football team for 2008 and 2009 football seasons are shown. Create a box and whisker plot for each data set, then describe the shape. Compare the distributions using either the means and standard deviations or the 5-number summaries. Justify your choice. What I have written on your screen, or on the screen for you right now, are the interquartile ranges from 2008 and 2009 times 1.5 subtracted by the first quartile and added to the third quartile. And you should kind of see familiarity here because what we're trying to find are outliers. It's important to note when you plot or graph a box and whisker plot, you have to exclude outliers. So when you're working through these problems, find the IQR, locate your outliers, and exclude them from your graph. I will show you what that means in the next slide. But to point out the fact that 51 is an outlier, we will not be putting that on the box and whisker plot. If 51 represented our maximum, while we found the 5-number summary, my new maximum would be the next largest data item that is not an outlier. In this case, in 08, it would be 35. So go ahead, make both box and whisker plots for 08 and 09 and compare yours with mine on the next few slides. So it might be a good idea to pause for now, make your box and whiskers, and then compare them with mine. Okay, so here is the box and whisker plot for the football scores in the year 2008. if you notice at the very top, I have 51 crossed off. It was my maximum. My new maximum became 35. However, remember, in the previous slide I said keep the 51 in there while you find the medians and the quartiles. The 51 really only comes into play when you have to graph it. And if you can notice it on the picture there, it's just kind of its own island. It's off on its own. That's what I mean by excluding the outlier. You will not attach it to the third quartile and create a really, really long whisker. Okay? So let's read into this a little bit deeper. If you take a look, the left whisker is longer than the one on the right, and the median is closer to the right whisker. Therefore, we have a negatively skewed distribution. And as a result, it would be a good idea to use the 5-number summary to describe this set of data. Okay, here's the box and whisker plot for the year 2009. The 5-number summary is above. The box and whisker plot is there in the middle. As you can see, the right whisker is much longer than the left, and the median is closer to the left whisker. Therefore, we have another skewed distribution, but this one is positively skewed. The other one was negatively skewed distribution. And on page 737, I'd like for you to, at some point, go through and read the explanation of how to describe and compare two sets of data in terms of their 5-number summaries. There's a very good explanation on page 737. I'd like for you to log onto your book and kind of read through that for a second. Besides that, you should be good to go to begin your assignment. On your homework in your book, they ask you to create histograms. I wrote on iCal that you do not need to do that. Create your box and whisker plots by hand, please, because you will have to do that on state assessments. And you will have to do that for our assessment, the quiz Wednesday, and the test the following week. Now, before we talk about this problem, there was another example problem with two sets of data creating box and whisker plots. Go ahead and, if you need more practice with that, you can go, by all means, go ahead and try it. Work that problem out with a friend, or ask your teacher for help if you still need extra guidance with the box and whisker plot. So there's a couple more slides to get through here, and they involve multiple choice questions. So let's just jump into it. A movie theater recorded the number of tickets sold daily for a popular movie during the month of June. The box and whisker plot shown below represents the data for the number of tickets sold in hundreds. Which conclusion can be made using this plot? Part A. The second quartile is 600. It looks like the second quartile is 400. This would be the second quartile right here. So that's not true. The mean of the attendance is 400. That's also not true because it's definitely not symmetric. If it was symmetric, perfectly symmetric, that could be more believable, but we have more variability on the right-hand side, so it's probably skewed. Part C, the range of the attendance is 3 to 6. It looks like we go from 1 to 9, so that can't be it either. 25% of the attendance is in between 3 and 400. So this part right here. And yes, I would agree with that. 25% of the data is in between 3 and 4. Okay, I believe we're on our last slide here. Interpreting box and whisker plots. The accompanying box and whisker plot represents the scores earned on a math test. Number 1, what is the median score? The median score can be found here, which is the second quartile. 75 is A. All right. Number 2. What score represents the first quartile? That would be 70. Quartile number 1, 70. Number 3. What statement is not true about the box and whisker plot shown? Part A says 75 represents the mean score. 75 represents my median, not the mean. Again, this is not a symmetric distribution, so the median and the mean are not going to be the same. So I'm thinking A already, but let's check the others. Part B says 100 represents the max. Agree? Can't be that one. Part C says 85 represents the third quartile. Agreed? Can't be that. Part D says 55 represents the minimum, and I also agree with that. So my suspicions were confirmed. 75 does not represent the mean score. It's not true. Number 4, and then we'll be done. Number 4 says a score of 85 on the box and whisker plot shown refers to what? This is 85. So this is quartile number 1. This is quartile number 2. This must be quartile number 3. And we're done. I believe you can go ahead and begin your assignment now.